So with our table of values, we get some points, and we are able to draw this graph. And this is the graph of y equals 2 to the x. In fact, what we're going to find out that's important is that if I get you to graph any, we'll do another one here, just a random. Pick a base. We did 2, you want to do 3, you want to do 5, really doesn't matter. If we did 5 to the x and wanted to graph this, the key things that are going to be in your graph are the following points. Plugging in 0 for x is always going to get you 1. Plugging in 1 for x is really easy. It's going to get 1, 5. An exponential graph will have an asymptote at y equals 0. And it will look like this. And this will be the 3 key things you'll draw on every exponential graph. 0, 1 is on all of them. 1, well, if you plug in 1, it's pretty easy math. 5 to the exponent 1 is just 5. 2 to the exponent 1 is just 2. So you're always going to have 1, whatever the base is. And because when you plug in a negative exponent, it flips it to the bottom, you're going to have an opportunity for something to get close to 0. We'll always have an asymptote at y equals 0. In the example that's next, we're going to we'll fill out the table of values, but we can also use the shortcut for this one. So I'm going to start with using this new graphing shortcut for all exponentials. I know that I'm going to have the point 0, 1. If I plug in 1, the base is a half, I'm going to get 1, 1 half. If I draw my asymptote at y equals 0, I now have these 2 points. And if I connect those 2 points, it's going down, so it goes down towards the asymptote this way and up this way this time. If we check that out with our table of values, here you would get 8, 4, 2, 1, 1 half, 1 quarter, 1 eighth. And we can review some transformation stuff. Okay? The graph in part A and the graph in part B have a lot of the same numbers. Can you see that they're just a reflection over the y-axis of each other? Which is kind of cool. So if I started with 2 to the x, can you see that a reflection over the y-axis could be written this way? And this is the same as this. My question is, can you see the algebra that makes those 2 the same? And I might play around with this like this. I can say, well, this is the same as 2 to the negative 1 times x. And a negative exponent is the same as putting that in your denominator. So we can see that 1 half to the x is the same as 2 to the negative x. That 2 to the negative x is connected to our transformations unit in that that would be a horizontal reflection.